Paper 2. Paper 2, CSE 2024. Chemistry optional. Paper 2, CSE 2024. Chemistry. पेपर टाइप इजी था, ट्रिकी था, प्लस लेंदी था. अटेम्प्ट विल बी मोर इम्पोर्टेंट. जो जितना अटेम्प्ट किया होगा. मार्क्स पोटेंशियल 120 से 170, वही जो फर्स्ट पेपर था. नाउ फर्स्ट क्वेश्चन फ्रॉम एरोमेटिसिटी. From aromaticity, that is, classify the following as aromatic, non-aromatic, anti-aromatic compound. 5 हैं, 5 नंबर के. That is, compound that is, compound cyclic, planar, number of electron, result, बस. एजुलिन, एजुलिन स्ट्रक्चर नहीं दिया था, इसलिए आपको स्ट्रक्चर बनाना पड़ेगा. एजुलिन that is cyclic, cyclic, planar, number of pi electron 10 pi electron. Aromatic. Pyridine, yes, yes, 6 pi electron. Aromatic. Signon, that is NR, that is cyclic, planar, yes, that is this, that is 6 pi electron. Aromatic. Additional information, mesoionic compound. Mesoionic compound. Now, cyclooctatetraene, that is cyclooctatetraenes. Yes. No. Non-planar. 8 pi electron. Non-aromatic. cyclic, yes. Planar, yes. 4 pi एंटी एरोमेटिक, बस। इससे ज्यादा आपको 5 नंबर में लिखने की जरूरत नहीं इन 5 मार्क्स। एक क्वेश्चन एरोमेटिसिटी से है, एज अपीयर। नाउ, though the following compound contain a keto group, it does not undergo nucleophilic addition reaction. Nucleophilic addition reaction is property of cyclic compound, property of carbonyl compound, in which nucleophile attack the carbonyl carbon. Now, consider the following compound, which is also a carbonyl compound, but this compound does not undergo nucleophilic addition because its ionization leads to aromaticity of 3-membered ring. That's why this compound appreciably exists in ionic form. In which carbonyl bond has appreciable single bond character with no electrophilicity. बस, इससे ज्यादा नहीं, 5 नंबर का। पार्ट बी, what intermediate is formed during the following reaction? Explain any one experimental proof for formation of intermediate. Now, plus NH2 minus, that is NH2 plus Br minus. Now, aryl halide generally does not undergo nucleophilic substitution under normal condition, but here aryl bromide undergo reaction with amide ion. This reaction can be explained on the basis of benzene intermediate. Step 1, that is formation of benzene. ये लिखना है, formation of benzene, NH2 minus, attack. unstable, that is, benzene is formed. This step is also called as elimination step. Now, in the second step, amide attack the benzene as nucleophile. Amide attack benzene as nucleophile. Forming another carboanion. Now this step is called as addition step. That's why such a reaction is called as, such a mechanism is called as addition elimination mechanism. Elimination-addition mechanism, sorry, elimination-addition mechanism. The evidence, experimental proof for benzene intermediate may be given by mass spectra. Whenever above reaction is done in the mass spectra, mass spectrometer, it gives a peak at 72, 76. It gives a peak at 76, and this peak disappear immediately. This peak disappear immediately by formation of a stable compound by phenylene. Now, evidence, that is, Br NH2 minus. Now, M by E 76. Due to dipolar structure, now immediately it dimerizes to this and peak at 76 disappear. So this is the evidence. How the following conversion 1C how the following conversion can be achieved? It is CH3H to CH3H Cl can be achieved. Now the given conversion is nucleophilic substitution reaction. Two broad process of nucleophilic substitution is SN1 and SN2. But in SN1, racemization takes place. And in SN2, inversion takes place. Here, we have to convert the alcohol into aryl chloride, alkyl chloride, with retention of configuration. That's why both SN1 and SN2 is not possible here. Another process of SN reaction is SNI reaction. That is substitution nucleophilic internal, which take place in presence of SOCl2, OH, ET, CH3H, SOCl2, heat. Now it gave EtCH3HCl with retention of configuration. Retention can be explained on the basis of mechanism. Step 1, that is, now chlorosulfite ester is formed. Now, chlorosulfite ester. Now, step 2, decomposition of chlorosulfite ester. Decomposition of chlorosulfite ester. Into intimate ion pair. Intimate ion pair. This ion pair then recombine to form the desired product. Since recombination of ion pair is always take place from same side, that is retention of configuration. Now, 1D Write the name of reaction and reagent required for the following conversion. सिर्फ आपको वही करना है, अगर आप टेबल बना दें तो और अच्छा. फर्स्ट, बेयर ब्लीजर ऑक्सीडेशन reagent per acid. Example, परबेंजोइक एसिड, मेटाक्लोरो परबेंजोइक एसिड, दो एग्जाम्पल भी दे दिए. सेकेंड, उल्फ किस्नर रिडक्शन, बिकॉज Clemenson reduction cannot be done because OH will be get affected. So Wolff-Kishner reduction, Wolff-Kishner reduction, reagent specific, NH2, OH minus. Alternatively, we can also use hydrazine in glycol solution. In glycol with sodium, where sodium glycolate act as strong base. Third, Dickmann condensation. That is alkoxide ion, that is alkoxide ion, that is methoxide ion, tertiary butoxide ion, etc. Now, Hofmann elimination. Hofmann elimination. Moist silver oxide. Fourth, Canigro reaction. Concentrated hydroxide, like NaOH, KOH, concentrated. ये हो गया 2 into 5. E part, following pericyclic reaction. 1E, following pericyclic reaction. One, two, three. 1, 2, 3, 4, 5, 6, 7, 8, 9. First step, 100 degrees centigrade. 6-membered, 5-membered ring. That is disrotation, disrotation, disrotation. Both hydrogen will be cis. H nu, ring opening, 6 pi, cone rotation. Now, trans, trans, 25 degrees centigrade. Now, further, this rotation, trans-cis, this rotation will give trans. M. Now, answering the following, predict the mode of ring closure opening at each of the 3 steps. First step, this rotation. Second step, cone rotation. Third step, this rotation. Right? Predict the structure of M. ये है M. Now, are the indicated hydrogen or cis or trans? यहाँ पे दोनों इंडिकेटेड हाइड्रोजन सिस है और यहाँ पे ट्रांस. All 3 answers. Now, second, 2A. Consider the following reaction. It is from a study of reaction mechanism. Consider the following reactions. That is, Br, ETO minus, Br, ETO minus. Now, KH by KD is 7.1. KH by KD is 7.1. Predict the mechanism and justify your answer. It is an elimination reaction. It is a elimination reaction. Which can take place E2 mechanism. E2 mechanism. Which is a single step mechanism. Which is a single step mechanism of even mechanism. Even mechanism. Mechanism to even mechanism. That is slow. Then ETO minus first. Another mechanism, even CB is ruled out because bromine is a very good living group. In E2 mechanism, CH bond is breaking in RDS state. So if hydrogen is replaced by deuterium, then a primary kinetic isotope effect is observed. While in mechanism 2, a carbocation intermediate is formed and rate determining step does not involve any CH bond breaking. However, due to formation of carbocation, if hydrogen is replaced by deuterium, a secondary kinetic isotope effect is observed. Now, KH by KD data 7.1 is a clear indication of primary kinetic isotope effect. That's why mechanism 1 is justified and this reaction takes place through E2 mechanism. तो ये आपको करना था, आप डायरेक्टली E2 करके मत कर दीजिए, ठीक? NH2 ओ ये ओ ओ एक बार आप लोगों को आज लॉग आउट होना पड़ेगा. थोड़ी सी रिकॉर्डिंग में प्रॉब्लम आ रही है. ओपन है। फिर ए इज पीएच NH2 plus CO CN COOET, that is ACOH, heat. Now it is Fischer, it is Fischer indole synthesis. Product is indole, substituted indole, that is NH. फिशर इंडोल सिंथेसिस हम जब भी करवाते हैं तो भी आपको इन एनी केस फ्रॉम साइक्लोहेक्सेन एक अलग से हम मैकेनिज्म आपको दे देते हैं। मैकेनिज्म, फर्स्ट ऑफ ऑल हाइड्रोजन इज फॉर्म। हाइड्रोजन बनाने की कोई मैकेनिज्म आप नहीं देंगे क्योंकि ये हमारे रिएक्शन में नहीं है। फर्स्ट ऑफ ऑल हाइड्रोजन इज फॉर्म। नाउ ACOH, now NH and that is CN COOET. Then mechanism start. That is H plus protonation. H plus protonation to give this nitrogen is protonated because it is involved in mesomerism. Now, after protonation, acidic hydrogen, enolization through acidic hydrogen. Now, this alpha hydrogen is more acidic as compared to this alpha prime. So, enolization takes place from this. Now, NH2. Now, इनोलाइजेशन यहाँ एरो पे लिखते जाइए। देन प्रोटोनेशन, अगेन प्रोटोनेशन टेक प्लेस एट दिस पोजीशन because still it is more acidic. Now, NH2 plus now 3 sigmatropic shift, 3 sigmatropic shift, 3 sigmatropic, that is 1 2 3 3 sigmatropic shift, इसमें एग्जाम देने वाले स्टूडेंट को टाइम लगा होगा अच्छा खासा, और हम पढ़ाते समय ही बता देते हैं कि इस रिएक्शन का सबसे बड़ा ड्रॉबैक यही है कि कभी कभी ये 5 नंबर में पूछ देता है। टॉटोमेरिज्म that is NH2 now SN2 attack, SN2 अटैक, इसके बदले में 10-10 नंबर के छोटे दिए हैं, 2-3 टाइम मेकअप करने के लिए। अटैक SN2 attack that is proton shift, prototropic shift, NH3 plus H. Now E2 elimination to give the final product which is written above. Final product which is written above. यहाँ मैकेनिज्म खत्म हो गया, ये आप लगा दीजिए। सेकेंड, it is scrub synthesis. It is a scrub synthesis of quinoline. It is a scrub synthesis of quinoline that is next to plus. H2SO4, H3BO3. Now, FeSO4, that is, product is this. Quinoline. Quinoline is product. Reaction start with dehydration of glycerol. Reaction start with dehydration of glycerol. The glycerol is dehydrated by sulfuric acid into CH2 acrolein. Acrolein. Now, अब देखिए इधर का कोई काम नहीं है, तो अब हम इसको बार बार लिख के लंबा नहीं करेंगे अपने मैकेनिज्म को. फर्स्ट स्टेप, माइकल एडिशन. माइकल एडिशन, एम ए, माइकल एडिशन. इस रिएक्शन में एम ए का मतलब सब लोग जानता है. माइकल एडिशन. सेकेंड स्टेप, that is H2SO4 protonation. Friedel-Crafts ring closing. Friedel-Crafts ring closing. Now, again protonation by H2SO4 and E2 elimination take place. E2 elimination take place. Here, aromatization is done by aromatization is done by boric acid. which act as Lewis acid, which act as Lewis acid. And probably mechanism is like this. Probably mechanism is like this. That is. NH प्लस इसको आप अलग से दे दीजिए, वैसे ना भी दीजिए तो कोई बात नहीं. That is this. That is the final product. Final product of the mechanism. Now, see, it is Hofmann exhaustive methylation followed by elimination. Hofmann exhaustive methylation followed by elimination. That is. First step is, that is methylation. One mole is required. 1 mole of methyl iodide is required here. And CH3 plus I minus is a poor base. That's why it is replaced by OH. OH minus. Now, attack takes place. At beta hydrogen to give attack takes place at beta hydrogen to give NME2. Now again MEI AgOH, that is again it is NME3 plus OH minus. Now again it is that is formation of one, two, three, four, five, six. 1,5 hexadiene is final product. ये आपका 15 नंबर का था और इसके साथ 5 नंबर का इसका सेकेंड पार्ट है. हाउ इज दिस कंपाउंड प्रिपेयर्ड यूजिंग रेफॉर्मेस्की रिएक्शन? How is this compound can be formed by using Reformatsky reaction? That is CH3, CH2, CH, CO, OH, Now, going back, working back, H2O, that is CH3, CH2, CHOH, CH3, COOET, COOH. Now, working further back, we have CH3, CH2, COH plus C, CH3, COOH. That's why reactant are propanaldehyde. Reactant are propanaldehyde plus CH3, CHBr, COOET in presence of zinc followed by H2SO4 heat. That gave CH3, CH2, CO, ZnBr, H, CCH3, COOET, which upon hydrolysis by H2SO4 give rise to CH3, CH2, CHOH, C, H, CH3, COOH, which upon heating with H2SO4 gave desired product. This is the product by Reformatsky reaction. Third A, predict the reaction mechanism and major product formed when methyl cyanide is heated with dilute hydrochloric acid. Methyl cyanide, 3A1, methyl cyanide, HCl, dilute, it gave acetic acid. It is hydrolysis of cyanide. It is hydrolysis reaction of cyanide which take place through acid catalyzed nucleophilic addition reaction. Step 1 mechanism, CH3 Cn, now H plus CH3 NH plus, now CH3 C NH plus, attack of water as nucleophile. Step 2, attack of water as nucleophile, CH3 NH plus H2O attack. Now it gave CH3 C OH double bond NH. Now Photomerization immediately to give CH3CO and H2. This is called as partial hydrolysis. Now, step 3, that is CH3CO and H2, that is H plus. OH 2, further attack of H2O that gave NH2. Now CH3 COH O minus NH 3 plus, or that is NH3H removed to give acid H product. This is simple nucleophilic addition on less reactive triple bond cyanide. Now, इसी का सेकेंड पार्ट है 5 नंबर का. ये आपको 10 नंबर में छोटा दे दिया था टाइम मेकअप करने के लिए. 5 नंबर में भी छोटा है. सिस टू ब्यूटीन, addition of bromine to cis-2-butene give racemic 2,3-dibromobutane, while trans-2-butene yield meso-2,3-dibromobutane. Justify. This can be justified on the basis of cyclic bromonium ion. Cyclic bromonium ion. Now, cis isomer plus Br. Now, cyclic bromonium ion is formed. Which again attacked by bromide ion to give Br, CH3, H, which is Br, H, CH3, H, that is racemic plus minus Dl. Similarly, trans isomer, where both CH3 are opposite side of plane. Now, Br, that give. Now, attack of Br minus. Now it gave Br, CH3H, CH3H, which is meso compound. Br, HH, CH3, CH3. That is the answer. 5 नंबर का है. Now, B part. Explain the formation of enone in the following reaction. 5 marks. Formation of enone in the following reaction, that is OCH3, $215 सेंटीग्रेड, 215 डिग्री सेंटीग्रेड temperature. Now, HCl aqueous, ETOH, HCl aqueous, ETOH, that is enone formation take place. COOET, Me. Now, it is electrocyclic ring closing. First step, electrocyclic ring closing. $215 सेंटीग्रेड disrotation, that is formation of this. Now, aromaticity of benzene ring is lost. Now, step 2, enolization, that is OCH3, HCl, ether cleavage, with formation of enol, which tautomerizes H, 1,5 tautomerism. 1,5 tautomerism. This is the pathway for formation of this compound. ये भी 5 नंबर का था. इसका सेकंड पार्ट है. सेकंड पार्ट 3b2 to classify the following sigmatropic reaction, rearrangement, and comment if it is symmetry allowed or symmetry forbidden. That is, it is product is this. Product is this. It is 3 sigmatropic rearrangement. 1, 2, 3, 4, 5, 6. It is 3 sigmatropic shift. That is 3 sigmatropic shift. Cope rearrangement. Cope rearrangement. It is called as cope rearrangement, which only take place in the thermal medium. It is interaction of HOMO and LUMO of the two allyl system. It is interaction of the HOMO and LUMO of two allyl system. That is CH2 HOMO and LUMO of two allyl system. That is HOMO of allyl system, LUMO of allyl system. Now, HOMO of allyl system is HOMO of allyl system having 2 pi having 2 pi electron is psi1. That is like this. LUMO is LUMO of allyl system is containing 4 electron is psi3, which is also symmetric. Which is also symmetric. Therefore, interaction of HOMO-LUMO take place with formation of bond. तो ये आ गया. Now sigmatropic shift. Now therefore transition state which involve the overlap of this is allowed. Now थर्ड पार्ट इसका फिर से एक बार पेरीसाइक्लिक से है. राइट द स्ट्रक्चर ऑफ मेजर प्रोडक्ट फॉर्म्ड इन द फॉलोइंग रिएक्शन. दैट इज CH3 OCH3. Heat. It is thermal 4 plus 2 addition. It is thermal 4 plus 2 addition. In which essential condition is that dienophile must substituted with electron withdrawing substituent. But here dienophile is substituted with electron releasing substituent. So rate of reaction will be slow. But reaction take place from that side where electron releasing effect is less. That is from the side of CH3. Regioselectivity is 1 to stereo is ring junction is 6. Consider the following conversion. C part. So that above conversion involves the formation of nitrene intermediate. Draw the orbital picture of singlet and triplet state of nitrene. Now, nitrene intermediate is formed in this reaction. Now, azide reaction, azide. Azide first of all react with acid chloride. It is a SM2 reaction. It is SN2 reaction. SN2 reaction to give acyl azide. Now, step 2, that is NN iso electronic decomposition take place to give nitrene as intermediate. Now, step 3, rearrangement take place at nitrene. That is RnCO. This is the product formation. Nitrene intermediate can be justified. Nitrene intermediate can be justified by addition of a small amount of alkene in this reaction. If in this reaction a small amount of alkene is added and 3 heat in presence of cyclohexene, another product NR is also formed, which is only possible through the addition reaction of nitrene. That is, nitrene undergo a characteristic addition reaction on carbon-carbon double bond to give 3-membered ring. Orbital picture of singlet and triplet nitrene are as follows. That is, singlet nitrene, or singlet nitrene, triplet nitrene, Rn, that is, sp hybridized, that is, Rn, one of sp hybrid orbital contain lone pair, two of the pure p orbital contain unpaired electron. Now, singlet carbene, singlet nitrene, that is sp, two hybridized, and two of the sp2 hybrid orbital contain lone pair. One sp hybrid orbital form bond. A vacant p orbital is perpendicular to plate. That is the singlet and triplet nitrene. 10 marks. Now, account for the following. Third, two-part. Indole undergo electrophilic substitution to give 3 substituted product but not 2 substituted product. Now, indole can undergo electrophilic substitution reaction at heterocyclic ring, 5-membered ring, where we have 2 positions. That is 1, 2, 3. Now, electrophile can attack any position. E plus, attack at third position. Okay? Attack at third position. Now, 3 attack, 2 attack. Attack at 2 position. That is. ऐसा तो हम खूब करवाते हैं कि नहीं? ये आ ही गया. E प्लस, बस अटैक करवाइए और चेक करिए स्टेबिलिटी. NH, now benzoid character of ring is lost. Benzoid character of ring is lost. For attack at third position, there are 2 intermediate is stabilized by 2 canonical form, in which benzoid character of at least 1 ring is maintained. But for the attack at position, only 1 such canonical form is possible. That's why attack at second position for attack at second position, intermediate is less stable. Required high activation energy as compared to attack at third position. So preferred position of attack is third position. E, progress of reaction. ये देखिए, ना ऐसे करके बना देंगे। ये देखिए, एच प्लस, ये एच प्लस। नाउ ये टाइम ये, now EA is less than EA prime. Now, according to Arrhenius equation, K A exponent minus EA by RT. Therefore, rate constant for attack at third position is higher than attack at second position. बस सेकेंड पार्ट इसका है कि क्लोरोबेंजीन डज नॉट अंडरगो न्यूक्लियोफिलिक सब्स्टिट्यूशन रिएक्शन readily. Now, chlorobenzene now chlorine is attached to sp2 hybrid carbon. That's why electrophilicity is less. Also, any attack of nucleophile is strongly repelled by electron. That's why possibility of SN2 is strongly discouraged. Possibility of SN2 is strongly discouraged. Now, due to mesomeric effect, carbon chlorine bond has appreciably double bond character. Appreciably double bond character, and departure of chlorine is not easily possible. Departure of chlorine is not easily possible. Even after departure of chlorine, phenyl carbocation highly unstable. So SN1 tendency is also discouraged. Both the SN1 and SN2 is discouraged. So chlorobenzene does not undergo nucleophilic substitution under normal condition. For A1, furan plus acetic anhydride BH3 in acetic acid in acetic acid. Now, Friedel-Crafts acylation. Friedel-Crafts acylation. Furan behave like a activated benzene ring. Therefore, it undergoes Friedel-Crafts acylation. Step 1 is generation of carbocation. Acyl carbocation. On acyl carbocation, attack takes place to give thereafter deprotonation takes place. Deprotonation takes place. To give the final product. Rate determining step is attack of electrophile. Because it is a electrophilic. Substitution reaction. And first step is slow due to loss of aromaticity. Second step is fast due to deprotonation. Energy profile is like this. E versus progress. That is EA1 A2 product. बस इसमें और कुछ नहीं देना है. Indicate the major product of the following reaction and point out mechanism as SN1, SN2, E2. दो है 5-5 नंबर के. ये देखिए CH3, 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 Br, that is ethyl alcohol, heat, ETOH, heat. Now Me3, COET plus Me2, CCH2. यहाँ मैकेनिज्म नहीं देना है. It is 3 degree substrate, protic solvent, heating. Therefore, minor product is substitution product through SN1. Major product is elimination product through SN through E1. Second, it is NH2, it is vinyl substrate. Therefore, nucleophilic substitution is not possible. Only possibility is that is elimination through E2 mechanism. E2 mechanism. Consider the following reaction. How would you confirm that above reaction is intramolecular by crossover experiment?
सर इसमें SN2 पॉसिबल नहीं था
ना, एकदम नहीं.
कॉन्जुगेशन तो नहीं है सर.
कॉन्जुगेशन मीन्स
सर कॉन्जुगेशन तो नहीं है तो बॉन्ड ब्रेकेज पॉसिबल.
एकदम नहीं. बट ये देख कॉन्जुगेशन नहीं है.
हाँ सर Cl के साथ अच्छा कॉन्जुगेशन कहाँ है. जब हम सर स्टेबिलिटी बताते हैं तो वहां बोलते हैं कि कॉन्जुगेशन अच्छा नहीं
है.
तो Cl का लोन पेयर है कॉन्जुगेटेड.
हाँ, और ये वाइनाइल सबस्ट्रेट है. वाइनाइल ग्रुप है ना
जी.
क्रॉसओवर एक्सपेरिमेंट. ये तो जैसा है वैसा ही कर दीजिए. 2 रिएक्टेंट ले लेंगे. इफ ओनली 2 प्रोडक्ट आर फॉर्म देन इट इज इंट्रामोलिकुलर रीअरेंजमेंट. If more than 2 product is formed, then it is intermolecular. Now, draw the energy profile diagram for conversion of benzene to chlorobenzene, giving a structure of transition state. 5 marks. आराम से हो जाएगा. इसमें nucleophilic substitution, benzene to chlorobenzene, electrophilic substitution reaction which take place Cl2, FeCl3, that is Cl. Now, step 1 is generation of electrophile, that is FeCl4 minus plus Cl plus. Now, Cl plus. Now, RDS due to loss of aromaticity. Step 2, that is deprotonation. Due to gain of aromaticity, this step is first. Now, energy diagram is like this, that is heat versus progress. That is benzene plus Cl plus. That is EA1. Now, intermediate EA2 product. First step is RDS because activation energy is high. Write the structure of major product formed in the following reaction. A. Pinacol-pinacolone rearrangement. 4. C1. पिनाकोल-पिनाकोलोन रीअरेंजमेंट, इसमें 10 नंबर में 3 है. It is पिनाकोल-पिनाकोलोन रीअरेंजमेंट. यहाँ पे लिख देंगे पिनाकोल पिनाकोलोन rearrangement. Product is this. This is product. It is Beckmann rearrangement. Beckmann rearrangement. First step, NH2OH, oxide form, NOH, okay? Thereafter, L2O3, that is CH3, CO, NH, CHME2 plus CH3 twice CH, CO, NH3. Both product will form depending upon the stereochemistry. बेकमैन रीअरेंजमेंट नीचे में ये लिख देंगे Third, Wegener-Mervin rearrangement. Wegener-Mervin rearrangement. That is H plus. This is 5 नंबर से भी कम के एक एक सवाल हैं, तो इनमें हम मैकेनिज्म नहीं देंगे. Write the structure of product in the following reaction and describe the step involved. 4C2 बहुत टिपिकल केस है. 4C2 normally it is Perkin condensation. This reagent and condition is for Perkin condensation. But Perkin condensation is reaction of benzaldehyde. But it is alpha difluoroacetophenone. Now, acetic anhydride generate the carboanion. Acetic anhydride generate carboanion. इसमें कोई दो मत नहीं है. Acetic anhydride generate carboanion. Plus KCOH. Now, enolization. Now, here carbonyl carbon is less electrophilic, but electrophilicity of alpha carbon is very high due to presence of 2 fluorine and 1 chlorine. Also, chlorine is a very good leaving group. Therefore, enolate attack at this position. Okay. COCH. Now, step 3, Friedel-Crafts reaction. Friedel-Crafts reaction takes place. That is ring closing. Now departure takes place. And final product is this. This is the final product. अच्छा सवाल दिया था ना। सेक्शन बी 5A, write the structure of the bases present in DNA and RNA, compare the stability of DNA and RNA। ये आप लोग कर लीजिएगा, इसमें वही लिखना है। ठीक। बी, predict the structure of PQR in the following sequence। In the following sequence, CH3 first, sodium in liquid ammonia, Birch reduction, here alkyne is selectively reduced to give the trans product, that is AP. Stereospecific. Now OSO4, NaHSO4, H2O. Now it is oxidative addition. Reaction takes place at more substituted pi bond. In the event of choice, attack takes place at more substituted pi bond. Therefore, H, CH3, CH2, CHOH, CH, CH3, OH. Now, that is Q, HiO4. It selectively और HiO4 रिडक्शन में जनरली स्मॉलर प्रोडक्ट पूछा जाता है, तो प्रोडक्ट आर एच, दैट इज CH3 एसीटोन इज प्रोडक्ट आर along with CH3 H, CH2CHO along with this. डेनमार्क, ये अच्छा सवाल पूछा है। सी, राइट डाउन प्रोडक्ट ऑफ फॉलोइंग फोटोकेमिकल रिएक्शन। 1, 5 का सी, फर्स्ट पीएच, CO, OC2H, O, C2H5 in isopropyl alcohol, isobutyl alcohol। क्या अल्कोहल का क्या रोल होगा? नो, alpha, beta, gamma. H nu, excitation. Now, hydrogen extraction. Nourish to. OH. Now, beta cleavage. That is pH, COH, CO plus CH3, CHO, acetaldehyde. Now, undergo tautomerism. PHCO, CHO products are this. 5 नंबर का ही है एक. सिमिलरली सेकंड में भी प्रोडक्ट बन जाएगा. नाउ अल्कोहल एक्ट एज सॉल्वेंट. सेकंड वाले में भी ऐसे ही करिएगा. पाइरुवियल्डिहाइड और एसिटेल्डिहाइड बनेगा इसमें. In the UV spectra of following pair D, which compound will have higher lambda value? In UV spectra, lambda value depend upon. In UV spectra, lambda value depend upon conjugation. Higher the conjugation, lower will be energy difference between HOMO and LUMO. Higher will be wavelength. Now, अब मुद्दे पे आ जाइए. फर्स्ट, पैराइसोमर. पैराइसोमर having longest conjugation. Longest conjugation. While in orthoisomer, due to repulsion, they are out of plate. So conjugation is highly minimized. Therefore, lambda A is greater than lambda B. Now, second, that is Exocyclic double bond, less involved in conjugation. Endocyclic double bond, more conjugation tendency. Therefore, here also lambda A is greater than lambda B. Third, cis isomer, trans isomer. Trans isomer, more conjugation tendency. Cis isomer, due to repulsion, less conjugation tendency. In trans isomer, repulsion free, more tendency for conjugation. So lambda B greater than lambda A. Fourth, longest conjugation from the para position. Longest conjugation. While from meta position, lone pair of NH2 is not involved in conjugation with NO2. That's why lambda A is greater than lambda B. 5. After conjugation, positive charge is stabilized. Positive charge is stabilized. But in second case, positive charge is less stabilized. Therefore, here also lambda A is greater than lambda B. E. In HNMR spectrum of following compound, how many signal will be observed in each case? Level and hydrogen in order of increasing chemical shape. Each set of protons in different chemical environment give rise to one NMR signal. Delta value of this signal depend upon relative shielding and deshielding effect. Now, Compound 1 is anthracene. Anthracene there are A, 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 B, 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 sorry, B, B, C, C. There are three NMR signal in which delta of A greater than delta of B is greater than delta of C, because delta C is attached to non-benzoate ring. Delta A and delta B, A and B proton are attached to benzoate ring, having ring with high benzoate character. Out of delta B and C, delta A is under more descending zone as compared to delta A. Delta A is under more descending effect as compared to B. 3 नंबर के now 2 A, B, B, C, C. But due to conjugation, this is the double bond character is less. Therefore, delta A, which is attached to more near to plus I effect, the delta value of A is less than delta value of B is less than delta value of C, which is attached to sp3 hybrid carbon. Here, only 2 NMR signal. A, B, only 2. Three NMR signal. डेल्टा ए आगे याद आ गई। हाँ, डेल्टा ए greater than delta C greater than delta B because delta B is under डाईमैग्नेटिक जोन। आपको दिखाने की जरूरत नहीं है क्योंकि 3 नंबर का ही है। ये एक बार अकेले में भी 10 नंबर का पूछ चुका है हमारे ख्याल से 2021 में। 2021 नहीं, 2022 में। तो ये 3 सिग्नल है। Explain the various steps involved in benzoyl peroxide initiated polymerization of ethylene to give the polyethylene। ये चेन पॉलीमराइजेशन का मैकेनिज्म डिस्कस करना है जो हम लोग एज सच लिखते हैं। प्रेडिक्ट द फिजिकल 6 का बी ए का 2 predict the physical property of a tactic, stereotactic, isotactic polystyrene based on their structure। आपको हम क्या बताए थे? Atactic is amorphous, isotactic due to stereoregularity is highly crystalline। तीनों का स्ट्रक्चर बना दीजिएगा, 5 नंबर का है। Write down the mechanism of formation। B, write down mechanism of formation of compound B and C from compound A on photoirradiation। That is photoirradiation of this compound। पंद्रह नंबर का है, 15 मार्क्स। H now H new initial excitation। Yes, sorry, N to pi star ट्रांजिशन। जैसा हम आपको करवाते हैं कि पहले फोटो केमिकल मैकेनिज्म, शायद यहाँ पे नहीं है, यहाँ पे है ना। N2 पाई स्टार ट्रांजिशन। S नॉट IHC triplet, triplet, T1. Now in the triplet state, alpha cleavage takes place. In the triplet state, alpha cleavage takes place. नहीं सात नहीं सात हाँ मंडे नो नो so now alpha cleavage takes place. Alpha cleavage takes place. Norris one, which is property of a small ring. Norris one. Now, now, CH2CO. Now, shift here to get that is the final product. That is the formation of product. निम्नलिखित अभिक्रिया C identify A, B, C, D in the following reaction sequence. That is A NaBH4, that is alcohol H plus, B C Br, okay? MCPBA D. Now A must be ketone. A must be ketone because upon NaBH4 reduction in methyl alcohol it gave alcohol. Therefore, A is this. Now this. A is this. Write the mechanism of first step of the above reaction sequence. NaBH4 से जो रिडक्शन का मैकेनिज्म है अच्छे से जो हम करवाए हैं उसको दीजिए. Now H plus BH acid catalyzed dehydration, that is even elimination through the carbocation, that is the B. B2C is allylic. Bromination takes place in presence of NBS peroxide. C. DH epoxidation. NBS का भी मैकेनिज्म, इपॉक्सीडेशन का भी ब्रीफ में मैकेनिज्म. बट फर्स्ट स्टेप का मैकेनिज्म आपको डिटेल में देना है. मस्ट बी गिवन इन डिटेल. Now calculate the lambda max in the following compound using Woodward-Fieser rule. 7 का A. 7A Woodward-Fieser rule. That is, first is compound like this. That is CO, this A, 6-membered ketone, basic value 215 nm. Now alpha, beta, gamma, delta. Now alpha alkyl, beta alkyl, gamma alkyl, delta alkyl. That is 10, 12, 18, 18. Double bond extending conjugation. DBEC 30. Homodiene, because both double bond are in same ring, that is 39. Now exocyclic double bond, 2 exocyclic double bond, 2 exocyclic, 10. So total value is 352 nanometer. B, B is this. Now, base value, basic value 215, अल्फा बीटा गामा डेल्टा, ठीक, अल्फा 1, बीटा 1, गामा नो, डेल्टा 1, अल्फा एल्काइल, बीटा एल्काइल, डेल्टा एल्काइल, that is 10, 12, 18 nanometer. Now, exocyclic double bond, no. DBEC 30, homodiene 39. Both double bond present in same range. That is 324 nm. 28 यूनिट कम हो गया. थर्ड सी, सी, that is CH सी है अपना, कौन सा है सी, अच्छा सी ये है, सी एच ये है सी. नो, सी होमोडाइन बेसिक वैल्यू 215 है ना. नो, अल्फा बीटा गामा डेल्टा, अल्फा एल्काइल, डेल्टा एल्काइल, एक्सोसाइक्लिक डबल बॉन्ड, 1 एक्सोसाइक्लिक डबल बॉन्ड, 18, 1 exocyclic, that is 05, DBEC 30, homodiene 39. Now, total value 9, 5, 14, 8, 22, 5, 29, 329 ml. तीनों में यहाँ एक एक्सोसाइक्लिक डबल बॉन्ड बढ़ गया है. Predict the structure of compound in the following reaction. Predict the structure of compound in the following reaction. That is N that is lithium aluminum hydride at 0 degree centigrade. Tetrahydrofuran. Only aldehyde can reduce. Only aldehyde get reduced. To alcohol. alcohol. So P is this. PQR है ना नहीं X. X is this. Second state P2H6 tetrahydrofuran. First, second H2O2 OH minus, that is hydroboration followed by oxidation. Now, why? यहाँ आपको हाइड्रोबोरेशन का ब्रीफली मैकेनिज्म बता देना है. Now, PCC that both 1 degree get oxidized to acid. Z. ये जोन्स रिएजेंट है. सॉरी, जोन्स ऑक्सीडाइजेज प्राइमरी अल्कोहल टू एसिड. यहाँ पे फर्स्ट और सेकंड स्टेप में रिएजेंट के सिलेक्टिविटी को बताना और सेकंड स्टेप में ब्रीफली मैकेनिज्म को रिजियो और स्टीरियो को बताना. 15 नंबर. C का 1 given below are NMR spectral characteristic of 2 isomeric compound with formula C10H12O2. C10H12O2. Now, double bond equivalent is equal to 10 plus 1 minus 12 by 2, that is equal to 5. Double bond equivalent 4 or more than 4 indicate the presence of benzene ring. So both isomer must contain benzene ring. Now, other characteristic HNMR delta 3H singlet, delta 3, delta 2 0.03H singlet, delta 2.93, delta 2.93 2H, triplet, delta 4.3 2H, triplet, 4.3 2H triplet, delta 7.3 5H singlet, 5H singlet. The last signal is due to benzene ring, and benzene ring is mono-substituted. Therefore, C10H12O2 minus C6H5. Now, that is equal to C4H7O2. One carbon oxygen double bond must be present because both of them give a higher band length 1730. Therefore, C4H7O2 minus CO that is C4H7O. Now 7 hydrogen are distributed in 3 groups, out of which one is highly disilted, 4.3. 2 hydrogen, maybe it is benzylic as well as directly attached to oxygen. Benzylic, benzylic, but this possibility is ruled out because it is triplet. One of oxygen is singlet. Therefore, OCH2, CH2, CO, CH3 is a possible structure for this. That is triplet, 4.3, triplet, 2.93, 2, singlet, थोड़ा सा CH2, CH2, O, 2.93, 4.3, O, CO, CH. It is directly attached to now 3H triplet, 2H singlet, isomer 2. Benzene ring plus CH3 triplet. That means attached to 3.72, 2H singlet, 4.13, 2H quartet. That is OCH2, CH3. That is quartet, triplet. Singlet 3.72. Quartet 2H. Quartet 4.13. 1.23. Both structure are formed. They are isomeric. In the mass spectra of following compound, prominent peak is at 58 and 92 are observed respectively. Write the structure of fragment and discuss the formation. Now, since both the fragments are formed at the even number, that means in both cases, double cleavage is involved. In both cases, double cleavage is involved. Maybe it is Nucleophilic rearrangement, which is very common in the phenyl ring having 3 carbon chain or carbonyl compound having gamma hydrogen. Now, one now plus electron minus 2 electron, that is formation of molecular ion peak. Now, on this molecular ion peak, now alpha, beta, gamma. Now, that is Nucleophilic rearrangement take place to give this plus CH2, COH, CH3, radical cation, which undergo photomerization to get CO, CH3 and M by E, T8. Similarly, second, M by E, 92. Even number means double cleavage. Plus electron minus 2 electron. That is molecular ion peak. Now, that is formation of HH. M by E, 92. Now, tautomerism takes place. That is in both cases, they are not base peak. They are prominent peak, but they are not base peak. 8A. Ethanolic solution of compound 1 on irradiation leads to formation of compound 2, 3, 4. The resulting reaction mixture exhibit band at 1787, 1740, 1714, 15, 1685. For carbonyl, assign this carbonyl stretching frequency to the corresponding compound giving region. कार्बोनाइल से 30 नंबर का आया यार, केवल 15 पहले पेपर में। ठीक, नाउ ये देख लीजिए, 1, हमको उसके रिएक्शन से कोई मतलब नहीं है। 1 is this, 1, 2, 2 is this. This 3, 3, 4, that is ester absorb at higher wave number as compared to carbonyl ketone. But whenever ring size is smaller, carbonyl absorption wave number is highest. That is, in second, carbonyl is attached to 4-membered ring, highly strained. So, this carbonyl absorb at the highest wave number, that is 1787. Now, the ketonic carbonyl in 6-membered ring is alpha beta conjugated. With a stable conjugated structure. That's why it is lowest 1685 सेंटीमीटर in work. तो हाईएस्ट लोएस्ट तो डिसाइड हो गया. नाउ ester having normal carbonyl range of 1740 centimeter in work, but here ester is involved in conjugation, so it is less. सबको अलग अलग एक्सप्लेन कर दीजिएगा, आ जाएगा. ठीक. बी, 2,2-dimethyl cyclopropanone undergo ring opening when attacked by methoxide ion, and product obtained possess the following spectral data: 1740, 1160. Now it is Fibresky rearrangement. B. It is Fibresky rearrangement. Fibresky rearrangement. MEO minus. That is OME. That is methyl alcohol. That is another possibility. Another possibility. OME. O minus. That MEO. That is B. Now, spectral data clearly indicate that it is both A and B are stuck. So we cannot ascertain by spectral data. But here, NMR data give only two types of proton is present. Only two types of proton is present. In B, A, B, C, D, there are four types of proton present. Number of signal does not confirm the structure B, but number of signal and their delta value confirm the structure A. A. That is, which is also evident from the fact that formation of A involve more stable carboanion as compared to formation of B. Now, fragmentation pattern दे दीजिएगा. Write down a structure of another possible product that is B. वो तो हम लोग पहले ही बना चुके हैं. फ्रेगमेंटेशन पैटर्न बता दीजिएगा कि क्या क्या है. What will be fragmentation pattern? Fragmentation pattern will be like this. ये देखिए, OCH3 plus E minus 2E, that is OCH3. ये हो गया मॉलिक्यूलर आयन पिक, और ये कहाँ बनाए भाई? ये बन गया 116 पे 160, पीक एट 85. ये that is MIE 85. MIE 59. MIE 59 OCH3, ये देखिए that CH3 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 plus M by E 59 M by E 31 OCH3 that M by E 31. Very less intensity. Intensity will be highest at 59, highest at 85 will be base peak, followed by 59, 116 and 31. J value, transcoupling is highest, followed by cis coupling 3, geminal coupling is lowest, that is 2. Two chloro 2,3 dimethyl butane on dehydrohalogenation can lead to formation of two products. Explain how the two products can be distinguished using HNMR and IR spectra. 10 marks. That is 2 chloro 2,3 dimethyl butane. Now, dehydrohalogenation, that is KOH. Now it gives two products, that is this plus this. Both can be distinguished by IR and NMR spectra. NMR spectra. All protons are equivalent. All protons are equivalent. So give only one NMR signal. One NMR signal. Here number of signal will be CH3, CHMe2. That is A, B, C, D, E. There are 5 NMR signals. 5 NMR signals. IR spectra. New CH bending. CH bending for symmetrically substituted tetraethyl is 850 to 900 centimeter inverse, while new CH bending for CH2 is 940 to 970 centimeter inverse. However, NMR is best. डाइइथाइल ईथर, मास फ्रेगमेंटेशन ऑफ डाइइथाइल ईथर हो जाएगा। डाइइथाइल ईथर, मास फ्रेगमेंटेशन प्लस इलेक्ट्रॉन माइनस 2 इलेक्ट्रॉन, M/E 74 molecular INT. Now, प्लस तो हटा ही दीजिए, इसमें प्लस थोड़े ही बनाते हैं। M/E सॉरी, यहां से शुरू होना है ना, यहां से माइनस CH3 फ्री रेडिकल। नाउ M/E 59, now 45, M/E 45, अब ये दोनों उल्टा हो जाएंगे। थर्टी वन, 31 ना, M/E 31 CH2 O CH2 CH3 that plus, now ये आ जाएगा। Using the following data, calculate bond length of HCl, हो जाएगा कि नहीं? रोटेशनल स्पेक्ट्रा, रोटेशनल स्पेक्ट्रा वो भी काय के लिए I इज इक्वल टू म्यू आर स्क्वायर, म्यू इज गिवन, I इज गिवन, HBr, HBr 1 4 product 1 2 product, thermodynamic, kinetically. Identify major product X in following reaction. B का 1, no evangel condensation. Second, Chaugev reaction. No evangel condensation तो पता ही है, ये है Chaugev reaction. ONL that is O minus take that is CH2 that is OCS S minus Na plus methyl iodide that is SME. Now, then heat. O SME that is ये देखिए चौगेव रिएक्शन सिन एलिमिनेशन। तो ये हम लोगों का पेपर था जिसमें हमको तो अभी तक दो ही ट्रिकी लगा, एक वो परकिन वाला और एक 31 पे जो मास का बैंड पूछ रहा है। वो जो नहीं बनाया होगा उसका नंबर ज्यादा डिडक्ट होगा।
सर मास स्पेक्ट्रोमेट्री से काफी क्वेश्चन आ रहे हैं क्या?
हाँ आते हैं